Howdy folks, welcome back to another CS 128 Honors Lecture. Today I'm going to be introducing you guys to some basic Rust syntax and showing you some basic programs along the way. So we're going to go over the anatomy of a Rust program, talk about variables and how to define them and create them, and introduce you to some basic variable types, go over macros, typecasting, and control flow, and finally show you some programs dealing with standard input and output. So I will be showing all of the lecture code today in a GitHub repository, so you can find that link in the video description if you'd like to follow along. All right, let's get right into it. So you're probably familiar with the main function by now. If you come from a C or C++ background, you'll know int main, int argc, char star star argv. That's a mouthful. If you come from Java, it's even worse. Public static void main string array args. Well, Rust is a lot more simple. Function main, and then you can start writing your code. Yes, I know these parameters are for environment variables, but there is another way to access those in Rust. Or not environment variables, program arguments in the command line. Anyways. So let's go over variables. You can assign variables using the let keyword. So let variable name equals value. So in this case, let x equal 5. So Rust will try to guess the value, or the type of the variable in this case. So Rust can see that it's an integer. More specifically, Rust will infer that this integer 5 is a 32-bit signed integer. More on that later. But best practice, always try and define what type of variable you want. So in this case, I want a 32-bit unsigned integer. Again, more on this later. So I'm going to define the variable type using colon, and then the variable type equals the value. This is always useful when you're working with other people. It makes your code more readable. It's just always best practice. All right, this seems easy enough. Let's get right into a program. So we have our little program here. We're going to create a variable x that is an unsigned 8-bit integer. We're going to assign it the value 124. I'm going to print hello CS124 honors. Oh, that's easy enough. So the thing to note here, though, is in my file structure, I have multiple main functions. So I have a main function in int.rs, I have a main function in main.rs. The way that you can sort of tell Rust which main function you want to run is by saying -- bin, binary, and int, the sort of name of the file. So cargo run -- bin int tells Rust to run the main function in int.rs. All right, let's see what happens. It's going to build the program, print out hello CS124 honors. Well, that isn't quite right. We're in CS128 honors. So let's add 4 to x and see what happens. Uh-oh, we got an error already. So cannot assign twice to an immutable variable x. What does that mean? So in Rust, all variables are immutable by default. You cannot change them. But you can specify to the Rust compiler that you want to change a variable by including the mute keyword after let. So in this case, let mute x equal 5, and then increment x by 1. So if we go back into our code example, let's sort of change this by saying let mute x equal 124. Try and run this again, and see that, there we go. Program compiles and we're printing out hello CS128 honors. Perfect. Okay, so that's the mute keyword. There is a different way to sort of assign variables. Let's say that we want to create a variable, perform like 1 or 2 calculations on it, and then keep it immutable for the rest of the program. Well, that's what shadowing is in Rust. we can define a variable and change it only a few times, but then keep it constant for the rest of the program. This is useful when we want to make an intermediate calculation, like in this example, we're computing the percentage using a ratio. And then we're going to multiply that ratio by 100 to get our final percentage. So rather than creating a separate variable ratio for this, we can just use the same variable name, percentage, and sort of compute the percentage. And as you can see, the value that percentage takes on in the first line of code persists and continues and is used in the second line of code, where we're multiplying by 100. So shadowing is very useful, but it can be very dangerous. So let's take a look at this sample of code. We have let spaces is some type of string, and there's like 6 spaces in here. But then in the next line, we're going to say let spaces equal the length of spaces, the number of spaces in this string. Well, our variable spaces changed type. Well, that's what shadowing allows you to do. The variable type can change between let calls. So it's always best practice to specify the variable type for better code readability. So in this case, let spaces equal &str, a type of string. I'll go over this in a little bit. And then in the next line, let spaces, the number of spaces, is a usize, a type of integer, the number of spaces in this string. So key takeaway, always try and annotate your variables using variable types just to make your life a lot easier. So Rust has 12 different types of integers. You got 2 different types, signed and unsigned. And then for each of those, you got different lengths of integers. So you got 8 bits, 16 bits, 32 bits, 64, and 128. And signed and unsigned versions of those. You also got the size type. Size type is the number of bits that your computer represents a pointer with, an address in memory. So this can be 32 bits or 64 bits depending on the computer you're on. These are sort of implementation dependent. So I know for a fact that on my computer, size types are 64 bits. And so my usize is effectively a U64. You'll often see usize as the variable type used to represent the length of data structures, so the length of an array, length of a hash map, et cetera, et cetera. Isize is similar. It's just the signed version of that. And so you might notice, why is I32 highlighted? Well, remember, Rust will always try to guess what type of variable you want to represent a value with if you don't specify it. So if you do not specify that your variable type is some type of integer, and you put in an integer literal, so like 5, 10, 15, whatever, Rust will guess that you want a signed 32-bit integer. This is the default. You only get a different type of integer when you specify the type, and Rust is able to see that you specify the type, and it'll give you that type. Okay, so Rust supports all the arithmetic operations you know, so addition, subtraction, multiplication, division, modulo, etc. It also uses the arithmetic assignment operators, so increment with plus equals, decrement with minus equals, times equals, and there are many more. It also supports all the Boolean expressions you're familiar with, so Boolean negation, exclamation mark, comparison operators, greater than or equal to, equals, etc. Biggest thing to note is Rust does not support the increment operators, so plus plus or minus minus. You can get around this using just plus equals 1 or minus equals 1. So just heads up, you cannot use plus plus or minus minus. So Rust also has characters, but Char represents a single character. You can declare it using single quotes. You also have Booleans, either true or false. You represent Booleans with lowercase t true and lowercase f false. Finally, floats. There are 2 different types of floats, a 32-bit floating point number and a 64-bit floating point number. The default value when you put in a decimal literal, so 0.0, 5.4, whatever decimal is, default is a F64. Rust will always guess that you want an F64 when you give it a decimal literal. So you might know these two types under different names. F32s are floating point numbers, and F64s have double precision. So you can be a bit more precise with F64 because you have more bits, more ones and zeros to represent that number. So something cool about Rust is that you can represent emojis with characters. In normal languages, you can only represent the ASCII table using a character. So, only a character is usually only 1 byte. But in Rust, characters are 4 bytes, meaning you can represent all Unicode characters, emojis included, normal letters, normal characters that you're used to. Just something cool. So here we're declaring the variable Ferris. The Rust mascot is a character, which is the Rust crab emoji. And here we're declaring a Boolean true, and then 2 different types of versions. F64 is 2.3, and previous F32 is 2.2. So in this line, let version is 2.3. We could remove F64 altogether, and Rust will automatically infer that 2.3 is of type F64. It's the default for floating point types. If we wanted an F32, we'll have to either specify F32 here in the declaration, or we can use some typecasting. So typecasting is trying to interpret some value as another type. So Rust uses the as keyword. We can sort of cast different types, so a variable or value as some other type. So let's go through this. We're doing some shadowing again. We're going to change my double a couple times and then keep it constant for the rest of the program. So you've seen this before, declaring a variable as an F32 is 0.0. If you do not specify the type you can specify it a different way with literals. So 0.0 F32, my double will remain an F32. You can also use the as keyword, so 0.0 in F64, because Rust will guess it's an F64, as an F32. So my double will remain an F32 in this case. Best practice though, annotate your variables with the type just to make your life a lot easier. We can also cast variables. So I have this variable my double, it's an F32, and I'm going to cast it to an F64 using the as keyword. And so Rust will see that, okay, I want this upcast variable to be an F64 because I'm casting it to an F64. So Rust will know upcast is an F64. Okay, let's get into an example. Okay, so I have these two sort of floating point values, A, which is pi, and B, which is E, and I want to add them together. I want to put them into an F64. Okay, well, you can already see that VS Code is warning me something is wrong. Let's see exactly what that is. So again, cargo run, -- binary, and then the name of the file you want to run from. And here we go. Mismatched types. Rust expected B to be an F64, but it found that it's an F32. So when you want to add two values together, they have to match types. So A is an F64, C, the result is going to be an F64, and so it wants B to also be an F64. So we can fix that. Right. Cast B to an F64. And we can run this. There we go. Add the two values together. We can do the reverse too. We can save the result as an F32 and sort of sacrifice a little bit of precision. So again, this will not work because Rust wants both types of the addition to be F32, and the cast A to an F32. And here we go. So you can sort of see because C is of type F32, we sort of lost some precision here. We can't represent as many decimal points as possible. and we're printing this out using a format string. I'll cover a bit more about what this syntax is in a little bit. Okay. So there is a unique type in Rust called the unit type. This sort of corresponds to a void in C or C++ or Java. It's represented by just open and close parentheses. It literally has one value itself. It is the open and close parentheses. It is the unit type. You might be thinking this isn't very useful, but it comes in handy in function return types when you want to have a void return type or return nothing, or in enumerations. We'll get into what those are in a sec in a future lecture. Keep an eye out for the unit type. Again, it's used when there's no other meaningful value that could be returned in a function. And you'll often see it in the return types of functions that don't return anything. Again, same thing as void in C, C++, and Java. So I lied a little bit. So when you have this function main, we're not returning anything in our main function. But this is actually the same as returning the unit type. Rust will sort of accept both versions. Or in any other function when you're not returning anything, you can either leave the return type blank or say that I'm going to return the unit type. Just to sort of sneak peek ahead into recover functions, this is how you declare the return type of a function. More on that in a future lecture, though. This is sort of obligatory. To declare comments, you have three different ways to do it. You have inline comments with 2 slashes, multi-line comments with a slash and a star, and then documentation comments with 3 slashes. So if you take any sort of Rust source code, you'll notice that functions are sort of annotated with these 3-line documentation comments. This is just a convention. It's a standard in the Rust community. Okay, let's go over strings. There are 2 basic types of strings. You got the capital S string, the most common type, and ampersand string, a primitive string type. Ampersand string is similar to a character array. Usually the capital S string is more useful for a reason we'll get into in future lectures. But biggest difference, string is ownership over its characters, which makes it more useful. String has a pointer to its characters in the heap, and it sort of owns them and can control them and manipulate them a lot easier than the ampersand string. The ampersand string stores its characters in the stack as it is a primitive type. Okay. So let's go over macros. Macros are a way to sort of write code using other code. They make your life as the programmer a lot easier. So usually in Rust, when you'd want to declare a function signature or use a function, you have a specific constant number of parameters, and each parameter has a specific type. Macros are a little bit different. They have a variable number of parameters and can take different types of parameters in different locations. I'll show you what this means. Next slide. So most useful macro, in my opinion, is println. You have this function called a println. Notice the exclamation mark. That's how you know that this sort of function is a macro. You have a format string, some string to print. This format string may or may not contain curly braces, and for each curly brace, you can specify arguments to sort of replace those curly braces with. So if I have curly braces, I'll replace the first set with arg1. It could be an integer, string, any other type, and the second curly brace with arg2. So println will print some formatted text on a new line. You also have print, which will accomplish the same thing, but there is no new line at the end. Finally, you have the format macro. Format will create a formatted string for you, capital S string. It'll take in this format string and then replace curly braces with these sort of arguments that you provide. So let's get into an example. We can print hello world. There are no curly braces here, so we do not need to specify formatting arguments. Same thing, print, but there's no new line after this. And let's say we want to sort of create a format string? Well, we have this sort of string literal here, and we have curly braces. And we're going to replace these curly braces with the value of favorite num. So I'm going to assign favorite num to 2002. And so at the end of this program, the string s will be a string that says my favorite number is 2002 without curly braces. So let's sort of show you what that looks like. Okay, if you're following along, you can open up string.rs. So a couple ways to create a capital S string. You can use string new, which will give you a new string with 0 characters. You can also create a string containing some characters from a string literal, so string from, and then in quotes, whatever characters you want to put into your string. A string literal is of type ampersand string. So this variable, a string, is an ampersand string that has the value fighting. And you can convert between these two. So you can convert from a string to an ampersand str using the as str function, or vice versa, you can convert from an ampersand string to a string using the toString function. And so you can call these methods on variables of those types, or you can call the toString function on a string literal and get a string sort of struct out of that. More on that in a bit in a future lecture. Another cool way to create a string is with the into method. So this requires that you specify the variable type. You must say that Illini is a string in order to be able to call into on an ampersand string. Rust will convert this type into the type of the variable. So that's important. And then again, another example of using a format macro. This gets formatted to say when I say ILL, you say INI. And we'll sort of print these out and show you what that looks like. There you go. So finding Illini, as a result of this format print macro. Then we're going to print this rally, sort of when I say IL, you say INI. You get the gist. So you can review this in the GitHub if you'd like. Okay. So let's go over control flow. This is very, very similar to many other programming languages. You have if, else if, and else. The nice thing, though, is you don't need parentheses around if statements. So if I have a Boolean, I can just say if my bool, and then enter my curly braces and print CS128 A bit more advanced, you can use the comparison operators. If x is less than 0, print x is a negative number, else if, you get the idea. Parentheses are optional. You can include them if you'd like, but they are not required. Just something nice. The biggest takeaway, though, is these types in the if and else if statements must be or evaluate to a Boolean. So if you come from C, C++, or Python, you'll know that you can represent Booleans with values like integers, floats, strings, where the value of 0 or empty string or empty list corresponds to false, and any other value corresponds to true. That is not the case in Rust. You have to use a Boolean inside if statements, inside while loops, whenever you're using any type of control flow. Another nice piece of syntax is you can assign variables some values using an if, else if, and else statement. Excuse the typos, but we're going to set a variable x to -5. It's a signed 32-bit integer, and we're going to assign y to the value of this if statement. So whatever this if statement sort of returns, that will be assigned to y. So in this case, x is less than 0, -5 is less than 0, so y is going to take on the value of -5 or +5, so y equals 5. If y was positive, y would take on the value x, which is 5. The biggest thing to note is that these sort of return types must match. So if I have a string here, I must have a string here. Another thing to notice is there's no semicolon after these. That's Rust's way of saying that you want to return a value. You'll see more of this when we cover functions. But if you want to perform this sort of syntax, there's no semicolon after the value, but there is a semicolon after the curly braces. Because this is a statement, you're saying let y equals some value, so you need a semicolon after that. And then we're going to print out the value. Okay. Now, on to our first example program. So we showed you how to print to standard output. Let's read in from standard input. So you'll notice this new piece of syntax here. Use standard IO. So we're trying to use this standard IO crate. I'd be asking, what are crates? Well, crates are wooden boxes, or well, boxes of any type. It could be plastic, maybe even metal. I like the metal one. Not really. Crates in Rust are binaries or libraries. So your project, in and of itself, is a binary. You're producing an executable. Crates could also be libraries, pieces of code that you pull from the central crate repository, crate registry, some other developer's piece of code that you can use in your project. So you import code from crates with the use keyword. Most commonly used crates are in the standard library. There are no sort of downloads or installations required. They are built into Rust. You can simply say use standard and the crate you want. So you can find sort of third-party crates on crates.io. This is sort of where all of the open source Rust crates are located. This website, crates.io, contains instructions on how to install any type of crate, get started with them, contains documentation. Super handy. This will come in useful when you begin your final projects towards the end of the semester. Okay, back to our program. So we're going to create a new variable buffer. So buffer is what we're going to use to keep track of what the user puts into the command line. So we're just going to create a new string, and we're going to want to be able to change this variable because we don't know what the user wants to put in yet. And then we're going to print out what's your name, and then this line is where we ask the user for some standard input. So IO SCVN sort of lets Rust know that you want to read in from standard input, and then read line tells Rust that you want to read everything the user types up until they hit enter, up until they hit a new line. And then we're going to pass in buffer so that whatever the user types is going to be put into buffer. Buffer is going to sort of represent whatever the user enters. And this is a little bit of a weird piece of syntax, ampersand mute buffer. This comes from Rust's borrowing system. We'll have a more in-depth lecture dedicated to borrowing in the future. All you need to know is we're sort of referring to buffer in this case. We're going to say we want to change buffer. So take the contents of the user's entry and put it into buffer. And then this .expect method down here. So this is a way to sort of handle errors in Rust. If for some reason we cannot read the line, well, we'll just stop the program then and there. We could not read and assign to the variable buffer, so there's no use continuing the program. Rust is going to panic and stop the program. But if Rust is able to read the next line, it'll assign that value to buffer and print out hello and whatever the user says their name is. Okay, let's take a look at this. So if you're following along, you can look up the io.rs file, and you can run this with cargo run --bin io. You can see Rust will ask, what's your name? I'll type in Neil. And when I hit enter, Rust is going to see a new line and then call this read line method. So enter, and Rust was able to read from standard input, and let's print out hello Neil. Awesome. So let's try and read from some files now. This is a lot of code. Understandably, will be confusing. So let's go over it line by line. So we're going to import the FS file crate from the standard library. We're also going to import some submodules from the standard input-output library, buffer reader and buffer read. Okay. So then we're going to start by defining our file name, source main.rs. We can use this into function because file name is of type string. So source main.rs, this is a string literal, and we're converting it to a string using .into. And then we're going to say we're printing the file source main.rs using this println macro. And then we're going to keep track of the line number, because what we're going to do with this program is print out the line number and then the contents of that line. So we're going to want to change the line number as we sort of go through the file. So use the mute keyword. And we're going to try and open up the file using the file name. So try and open up the file name. If for some reason the file doesn't exist or we're not able to open it, we're going to stop the program then and there, panic, because there's no use continuing. There's no use sort of introducing undefined behavior of trying to read a file that does not exist. So if the file does not exist, stop the program. Otherwise, we'll keep on going. Use our buffered reader to sort of read the file. So buffered readers are useful because they read files portion by portion incrementally. They do not open up the file and read everything at once. They'll give it to you piece by piece. So this is useful in large files, if you want to save on memory, whatever the reason may be. Okay, and then we're going to go through the contents of our file using contents.lines. And so for each line in the lines of the file, we're going to print it out. So we're going to print out the line number, print it out as if the line number were 2 digits. So if the line number is less than 10, we'll put a little blank space where the 10th digit would be, and put the line number where the 1st digit is. I'll show you what that looks like when we get to the example. And then print out the contents of the line. So line.unwrap. Unwrap sort of gets the contents from the line. This, again, goes back to enumerations, enums. We'll cover more what this means when we get to that lecture. Just know that unwrap gets the contents of the underlying string from the line. And then we increment the line number, sort of move on to the next line in our for loop. So let's take a look. If you're following along, you can look up file.io.rs. Change this back. So we run this program. It'll take in the contents of main.rs. You can see here, this is what the file looks like. And here we go. We're printing out the line number followed by the contents. And you can see that we're printing out this file in its entirety. Okay. So what happens if we give a file that doesn't exist, say like main.txt, like it was before? You can see there's no main.txt here. Oops. Fix that. So Rust will try and open up this file, but we'll notice that the file doesn't exist. So the program will panic. It's not crashing, it's not segfaulting, it's just going to exit immediately. And we see here something went wrong reading the file, so this expectation here. And it's going to print out some debug information. So there's no such file or directory, no file main.txt. All right, that is all, folks. Thank you for watching this second lecture. Here's some sort of ideas of things to explore in Rust if you'd like to practice what you learned today. You can make a number guessing game. You can hard code a number and sort of take in input from standard input and have a user try and guess your number. Bonus points if you can find a way to make that number randomly generated. I'd assume you need a random number generator crate, so you can use crates.io for that. Another idea is to make an adlib program. You know how to format strings, you know how to format print statements using format strings. Bonus credits if you can write the output to a file. You know that there's the standard FS crate to use. You can look up documentation for how to write to a file. Or make up anything else you can think of. We'd like to see what you guys can create. Post in Discord. Send us Discord DMs. Let us know what you make. I'd love to see what you guys can think of. All right. Thanks, everyone.